your guys' understanding of what data science is and like what your experience with it is. So let's take a little brief survey. If anyone wants to volunteer and answer, what do you think data science is? Anyone, feel free to chime in. Go ahead. That's good. That's part of it. Anyone else? So I'll go ahead and say it. Data science isn't any one specific thing. To some people, it's machine learning. That's the first thing that stands out. And that's very much true. A big chunk of it is machine learning. And that's pretty much what differentiates data science from data analytics. Data analytics also uses Python, R, SQL or SQL, however you want to call it, Excel, and so on and so forth. But it has one extra layer that differentiates it from data analytics. That is data science, of course. And that is feature engineering. So you're not just looking at columns of data. I mean, that's part of it. But you're looking at columns of data such that you can create new, unique columns of data that help the interpretability of the ultimate end goal, which is to build a model and predict something. So that's predictive analytics. And then, of course, there's also prescriptive analytics, and that's when you go into production with some kind of a machine learning model. But in a nutshell, that is a good answer. That is part of it. It is analyzing data. That's a big chunk of it. So rather quickly, my name is Leon Spanner. I'm a UCLA alum, graduated in 2007 with a degree in economics. At the time, they didn't have this class, which I found fascinating that they even involve data science and economics now. I think it's really cool. I wish I had that class. And since then, I went on to work in finance, accounts receivable, workers' compensation, work at a law firm, and then eventually somehow some smart person decided that I would be a clinical researcher doing bioinformatics. I never studied medicine. So like, I don't know how I got into it, but I will tell you this, and hopefully my slideshow will kind of elucidate some of these points that, yes, thank you. That you can start in one place, but ultimately end up somewhere else where you never thought or ever imagined. But how you get there, and some of you do know what you want to do, some of you don't, and that's okay. For the longest time, if somebody asked me, for the life of me, I had no clue what to do with Excel, worksheets, workbooks, and Lagrangian multipliers. But that being said, we already answered the question, what is data science, very vaguely. And some of you, and I heard Professor Boswell talking about ARIMA methods, that's autoregressive integrated moving averages. I remember that. That's really cool. Hope you guys enjoy that. So yeah, that has to do with statistical and computational methods. I'm gonna say this really quick. If you had to pick something to know for sure, like on a job interview, know what a p-value is, know what statistical significance is, know what is a hypothesis testing framework. So you start off with the null hypothesis. I don't intend to make this like a boring lecture, but you start off with the null hypothesis. That's your baseline. You establish your baseline. You counter that with the alternative hypothesis. And then that's basically your framework. You either prove or disprove that essentially, or you find out if it's correlated. Be very careful with correlation versus causation. That's another thing. So at a minimum level, understand that, understand goodness of fit, things like that. So that's what we mean when we talk about statistical and computational methods. And then, of course, the most important part is collecting, gathering, and transforming the data. That is the most mundane, but very necessary portion of the whole process, because everybody wants to jump to the model. Everybody wants to see the cool, fun-looking graphs, which they are cool and fun. And to this day, I love getting output. It still excites me. That's why I still do what I do. But you can't neglect the very necessary piece that involves gathering and collecting the data. And sometimes, if you're lucky, your first project, when they bring you in, they give you a nice, clean CSV file. So you kind of start off with that, and thank God that you proved yourself at least in that way. If you're not lucky, they give you a bunch of separated CSV files that you got to join together using SQL, and that becomes a whole animal in and of itself. So moving past that, let's go to the next slide. So that's the basic introduction. And like I said, there's machine learning, data visualization. Some of you might fall in love with that because that's a whole other component which has its own set of rules. It is cool in the sense that you get to, it's kind of like your baby. You get to do with it whatever you will. But please, and I beg you, do not ever draw a 3D pie chart or a 3D bar chart. Those are the worst. They distort the perception of reality. I mean, that's my own biased opinion. I mean, that's the way I was taught. But just try to keep it simple. Always pay attention to detail with the colors because some people may be colorblind. So you got to keep that in mind as well. And that's data visualization. Some people love to tell stories with that, maybe using Tableau, maybe using Power BI. Don't worry about which one you got to learn. Somebody once told me, look, you don't have to learn it all. If you learn one, you can learn the other. And I think the same thing goes for R versus Python. We can get into that a little bit as well. Let's see. Oh, there we go. So yeah, these are some of the technologies. Microsoft Excel, R, or R Studio, where you do R, Python, SQL, and there's PostgreSQL or Postgres as they call it. There's MySQL, Microsoft SQL Server, NoSQL, no one really uses that one. And so, yeah, and then there's Git. Now, it's important to differentiate Git versus GitHub because Git is the version control, quote unquote language, and GitHub is the online interface where you put stuff that you use Git to with version control, so other people can collaborate with you and things like that. So, so that's basically it. So when I started working at the film school, I'm not going to tell you which one. The end goal. Well, let's start with this. In finance, you can build an ETL pipeline. That's if you want to take your existing financial reports and move them over to a proprietary software, like, for example, Profix. It's a CPM software, which stands for Corporate Performance Management. And the key to that is to automate existing processes because you don't want to pump out the same Excel spreadsheet every single month. And they hire some entry-level accountants to do that. That's what we used to do back in the day. But now things have gotten more efficient. I don't need to tell you even about ChatGPT. That's a whole other next level. But as it pertains to this ETL pipeline, we'll get into that in just a moment. That I'll tell you rather quickly. It means extract, transform, and load. Some of you may already understand that as well. And then when I was working at this film school, our ultimate goal was to automate these cost center reports using VBA in Excel. And I'll explain why we kind of went that route as well. But in the beginning, I started off in accounts receivable. And as you see here, you should be familiar with this multiple linear regression equation. Y is your dependent variable. You have your coefficients. And my goal, and I proposed this to my boss, was to predict the accounts receivable in some time period X. The was independent of a time series analysis because that's the next step, but she didn't really want to hear me on that. So we had these independent variables, the inactive side, which number of days that the account was inactive, that's one of the independent variables. Then we had the current balance and ... We had some more because you always want to have a few features in there. It's difficult to build a predictive model just off 2 features alone. But essentially that was our goal, is to predict the price trajectory, the collection trajectory, like how much money could we collect at a given time T. So moving on, what I did over there, and this was at the time where I had somewhat of a limited understanding of data analytics, if you will. Let's see here, just look one time. Yeah. So I brought this into PowerPoint. We had this playing on the TV in the office, and I added this visual component. This is where data visualization comes into play. it was easier to see, at least for me, how to track these numbers on any given month in any given year. And this is for 2013 through 2017. You could see the trend. It's kind of fluctuates at around 310 to 510K, it kind of goes down and then goes up. So your first thought might be, why don't I just do a time series analysis? And that's kind of what I told my boss. She says, like, you're too technical, Leon. I don't understand what you're talking about. I said, okay, well, these are the numbers. And then let's just kind of click through those really quickly. And you could see year over year, there were spikes, peaks, and troughs, and so on and so forth. And we did improve our collection efforts, as evident in this last year of 2017. And of course, we were able to predict like how much money we would end up collecting in years 2018 and so on and so forth. And I think they're still using that model today. Now, that being said, yeah. So this is what my boss thought. Machine learning models everywhere. It's like, but she doesn't really understand what the end goal is. And, you know, like I said, well, yeah, let's, is this thing kind of trying to, yeah, there we go. Yeah. And so then that was the system that we brought in. I didn't have a choice in the matter. They decided on profits. And so that was the final word from the boss. And this is normally what a robust ETL pipeline would look like. Unfortunately, I only had access to the general ledger. So on the left-hand side, that middle square, they didn't give me access to the ERP. I think communication is the biggest challenge. It's not so much learning the tools and of the trade, is really trying to convince people what you need, what you're trying to do, why you need it. And I just didn't get access to the ERP till much later. And HR, no way, forget about it. So it was just that middle piece. Ultimately, that goes into Microsoft SQL Server or whatever you use for the data and storage layer, goes down through the application layer. And the ultimate end goal should be it spits out like a nice dashboard through one of these, like Tableau or something else. And here we go. And so that's basically another view of what a ETL pipeline looks like. And again, that stands for extract, transform, and load. And basically it's a process, and let me explain it a little further. In data warehousing and data integration, used to collect data from various sources and then load it into the target system, like a data warehouse. And it's very necessary for consolidating, managing, and data from different sources, so such that businesses can make data-driven decisions and perform analytics. That's the long and short of it. Now, I think it's important to make another distinction. So I said earlier that data science is not necessarily data analytics. And in a similar fashion, by the same token, data science is not data engineering. No matter what people tell you, I don't care. I mean, I know that sometimes data scientists have to perform the work of data engineers. And if you're that unlucky person, and maybe lucky depending on how you want to look at it, then by all means do it. But if that's all you're doing is working with SQL and just crunching that, like basically they call it a SQL monkey pretty much. I don't know who invented that term, but it's up to you. If that's what you want to do, then that could be the path that you choose. But in any event, like I thought I'd throw in a little cartoon in there showing a data engineer hanging on to a data platform, and then also at the same time to the data scientist, and kind of being stuck in the middle. And that's really the best interpretation of what a data engineer is. I mean, just one, I guess. And then here's another cartoon with Rick and Morty. Robot comes in and asks, "What's my purpose?" Like, pretend that robot's a data scientist on the job on the first day, and he's told, "Well, you write SQL queries." Oh my God! And that's all that they do, unfortunately, sometimes. But this is very necessary. So If some of you are already familiar with SQL, this is like a basic table. You would just select the customer name, and then the email, order date from this table called orders, where order date is like, for example, you want to select something that's at least in 2022, January 1st, but less than before 2023, January 1st, you would write this query. The reason I'm showing you this is very simple, is because I know you're going over R from what I was told, and this is exactly how it looks in R Studio or wherever you write that R code. Pretty much the same. The whole purpose of this is when you strip away the code, next slide, please. It's basically the same SQL query. So you just add a little bit of a code component to it on top and in the bottom, and you're able to garner the same results. So it's really, don't be afraid of using different technologies. You can do the same thing in Python. It's very similar. You connect to the database and then you execute the query. So, and that's that piece. But, you know, going into another application of data science, I decided to volunteer for a cryptocurrency company, a prominent one. And they weren't looking for a data scientist. So I just kind of just nudged my way in the door and I said, I know you guys are looking for a software engineer, but I'd like to implement data science here. So if you end up kind of in a company like that, or if you're the sole proprietor data scientist, where you're the only person doing data science there, be careful, really know your stuff, but don't be afraid to take risks, because like what I ended up doing essentially for the longest time, maybe the first year, since I was a volunteer, I didn't really have to do anything per se, but initially it just started with visualizations, and I was tracking event activity within the app itself. So it's not that attractive. I wasn't really tracking the price movements of the cryptocurrency per se. It was just boring, like event activity in the app, but that still led to something. And eventually, when I did get access to the data through Google Analytics, I was able to do this k-means clustering algorithm in R. And I'm a little bit biased when it comes to R in this regard, because I personally think it's a lot easier to execute a k-means clustering algorithm in R. It's quicker, it's more efficient if you have very limited amount of data, versus Python, where, I mean, it's similar, but you just end up writing a little bit more code, and the visualization isn't quite the same, in my personal opinion. In R Studio, you could just spit this out with fviz-eig. It's a function. And the whole purpose and point of this is that if you look at this cluster number 3 on the very right-hand side, notice, and I on purpose did not disclose like what those dots are. These are devices. We can call them like phones, iOS devices, Androids, et cetera, et cetera. So it's the device name plus the operating system. And you can see that in cluster 3, you have a lot of those, right? So at a base level, we want to know, why are there so many devices in cluster 3? How do we get them over to cluster 2? So at the marketing meeting, I proposed, let's get them over to cluster 2 and it's like maybe launch some kind of a targeted marketing campaign. And this is where there's a communication gap, because you kind of have to know what marketing does, and marketing kind of has to know what you do. But I'm going to say, and this is again because I'm very biased, that don't go into a field that you're not quite, you don't quite understand, because if they don't understand what you do, like, you didn't study marketing, well, they didn't study data science, so there's going to be a bit of a communication gap. So I left that volunteer post, but I was able to kind of get at least that experience from it, which is why I'm very happy that I'm in healthcare, because at least when you're working with healthcare professionals, decision makers on that front, they have a better understanding of what data science is, because it's the true meaning of the word science. They are doctors, they are scientists, they know some basic statistics and bioinformatics, and you can kind of speak the same language. So there's that trade-off. Let's see if we can go to the next slide. Oh yeah, which one is it? Keep clicking this one. Yeah, and so yeah, on that front, the biomedical clinical research side, I want to highlight a few things that I thought are very important in terms of models, which I'm sure some of you have already done or will do at some point in the future, spit out models, but at the same time also be able to properly conduct performance assessments. So it's not just a matter of spitting out metrics like accuracy, precision, recall, the F1 score. I mean, those are important, but it's also very important to kind of be able to understand what the raw curve is, which is the receiver operating characteristics curve, and how to sweep through it and really understand the trade-off between the sensitivity on the y-axis and the false positive rate on the x-axis. So, for example, I couldn't really use the particular data set that I was working with when I was at another hospital. So this is from another project I did relating to cervical cancer from 858 patients. I think you'll find this on the UCI machine learning repository. Cancer in general is just a terrible thing. It's but it's very important to study. And again, there's 858 female patients, teenagers all the way up to 80s. And with these 858 patients, once you go through the steps, you clean the data, you process it, and you run the algorithm. Notice how in this particular logistic regression model, what I want to highlight is there's this, which one's the laser pointer? It's the top, thanks. The, where do I point it? Oh yeah, let's see, it's not doing it. But if you look at the bottom portion right below this yellow diagonal line, there is a drop off in performance. So that yellow diagonal line is the baseline, and the model is kind of above the baseline, but it's from like around 0 before 20% sensitivity, even before 1%, 10%, it's dropping off below the baseline. And same thing with the false positive rate, it's also falling below. So it's not the best model, at least not at those thresholds. So performance starts to kind of go up past 20% on both fronts. But what I want to highlight is once you get into something like the support vector machine, SVM, you notice an immediate improvement in performance, and you can see that the AUC, or the area under the curve, goes, I think in logistic, it was like 65%. Here it's 94%, so it's very robust in that sense. But, and I can't stress this enough, we as data scientists are not defined by our AUCs alone. You can't just say, look, I got 94% AUC and that's it. Because what in a clinical context, it means almost nothing. Because if your decision, it all depends on what the stakeholders want. For example, so I can relate this to an actual project I was working on at a children's hospital. I was tasked with a binary classification problem to determine whether or not a child would die. We already knew the child would die. Whether or not the child would die within an hour after they remove the endotracheal tube, or beyond the hour. Now imagine if you have to explain this to a physician using this, and you pick this model, or let's even go back and with this model, let's say you decide to use a logistic regression model, and you want to go into use this in production. At every threshold on the TPR on the y-axis, you have already an immediate like trade-off. You already have for every one of those, you got false positive, you go up, false positive, you go up some more, false positive. Now, do you really want to constantly keep alerting the physicians that, no, the child it's not really going to die? Don't tell the family. Oh, wait, no, actually do. So you have to kind of weigh that in. That's what's really important in that particular case. And notice how that improves with the SVM. But I want to say something very important about the SVM. If you ever decide to use it, it's not computationally efficient. With something like 858 size n observations, you could get away with it, maybe using something like the, I want to get too advanced, but like radial basis function. You could try to use the linear kernel, but typically I would try to stay away from this unless it's a smaller data size. But here's everyone's favorite, the random forest. That's what everybody likes to use. And so it's, notice how the performance immediately improves. You have a very high AUC, which is very unlikely you're going to get something like 99%. But that's, I'm showing you a publicly available data set, so it's a little bit different. But like I said, from the very beginning, this is what everything looks like together, 3 models combined. I would, I know people like to use these tables, which is fine. You can spit something out like this, but I would urge you, in my personal opinion, I can't tell you what to do, and I kind of don't want to give unsolicited advice, but this is what I'm biased on. This is the way I've been taught, is don't just report these metrics like that unless you can explain like one versus the other, what's more important. So that's pretty much what I want to say about that. There's data science from my limited perspective and experience in a nutshell. And if I want to say thank you for letting me speak to you today. If you want to follow me on social media, here's my information. Thank you very much.
Okay. So now we're gonna open up the floor to questions. Do you have any industry related, data science related questions? I know this is a little, for those of you that did 103 with me, is a little different from the presentations that we would have seen before. But if you have any industry related questions, job search questions, or data science questions, now is the time to ask. We'll open the floor up to questions. If any of you have any in the Zoom, you can type it in the chat. If not, stick your hand up. If not, I have one, and then we'll wrap it up. Okay.
Slide 15-minute presentation. How do you condense all that? How do you relay that information? And why is it important, right? And that's the challenge. So if you can do that effectively, I think you're a winner. Anyone who could do that effectively is, my hat's off to you for sure. Yeah. Oh, there's something up there. Yeah.
Right? That's something to remember to the audience. So not everyone's gonna have a data science background. So when the projects call for commenting on the output, so commenting on the overall truth of the model, or commenting on the interpretation of variables, or the statistical versus the economic significance, those things are important because those are what will carry over in the field when you're explaining to your employer or whoever may not have a data science background, what exactly is involved. So the other question is, what did you discover from the accounting?
Yeah, there was seasonality for sure, and that's why I proposed that we, do some time series and remove the seasonality, you know, vis-a-vis stationarity and all that. But like I said, they weren't having it. So we had to kind of like, that's a good question. We just had to track it, historical trends over time, and just kind of, I hate to give this answer, but the truth is we kind of eyeballed it, which is, you know, we knew we had a certain collection rate over a period of time. And so our goal was to maybe even subconsciously like collect at that rate. And that's why we were able to climb. And of course, this is actually a good segue into something else where if your model performs differently, that is what they call model drift, because practices change over time. So that's kind of like something was going on in the back end to nudge that. And so, yeah, that would be an interesting question to solve. I know that they're still using those graphs. I heard they're still using them to this day. But that's as far as I know. I don't know what else they're doing. Okay. Go ahead. Mm-hmm. To me, that's a bit of a murky topic. Like, what do you mean exactly with like economic consulting per se? Like a company like Rand, for example? Is that somebody that does that? Mm. Mm. Yeah. 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 No, I don't have any experience on the economic consulting side, to be honest with you. Anyone else? Okay, well, I guess that's it then.
We'll call it a close today because I would continue with the lab information, but most of you aren't even here. So I will continue on Monday. We'll finish out time series and then we'll move into the next topic, which is autocorrelation. So use the weekend, look through your project information, ask all the questions. Please don't wait until the end. Groups are open. You can switch around to different groups now. Else?